Hey, everybody, welcome back to the Muscle Intelligence Podcast. I'm your host, Ben Pakulski. Genetics has completely changed the way I approach my health, my performance, and ultimately the life and health of my family. And today I've brought on two incredible guests from the company Fitness Genes to walk us through some of the foundational things you need to know and understand to ultimately live a life that's harmonized with your genetics. What does harmonized mean? We all have different tendencies and predispositions, and living in alignment with that will allow your body to be less stressed, more in alignment, and ultimately, we believe, perform more effectively. Today, Sam and Alex, thank you for joining me. I'm so grateful to have you guys drive down. And I guess, Alex, you're here in London, but Sam took the train in. So thank you guys for joining.
Thank you very much, Ben. It's a pleasure to be here.
Absolutely. So, Sam, you're the CEO of Fitness Genes, a company that I've known and worked with for a long time. But just recently, we reconnected and rekindled, and you guys have just completely blown my mind and blown open my concepts of what an ideal performance plan is. You know, we were doing performance coaching for men. We're looking at blood. We're looking at urine. We're looking at stool. But the missing link for us, now that we see it, is like, oh, it's genetics. Because what genetics has done for us is allow us to see where you're strong and where you're weak genetically, where your tendencies and predispositions are, as I said in the opening, and really allow us to laser target. For me personally, there's been like 5 or 6 things that, I think what everyone's looking for is clarity and certainty. So people are like, can you paint the clear path forward for me? And for my genetics, it's like, I know I need these things because I'm genetically inadequate there or genetically deficient there, we'll say, maybe you can correct me on terms. But that's just completely blown it open for me, right? Because we're looking to create some version of confidence and certainty in our programs.
Yes, and I think one of the things that you just mentioned, a whole load of sort of biometric factors there. Genetics is the piece that pulls it all together. So it's about understanding how you respond to different interventions based on what your predispositions are. And just as you said, Ben, in genetics, there's not necessarily good and bad. Obviously, we do have some sort of disease genetics, which undoubtedly we would say, those are things that we don't want to see. But what we do at Fitness Genes is we look at variants which impact on physical performance. So we're looking at an array of genetic variants which will essentially give you a focus. So by having a better understanding of your genetic portfolio, it's sort of creating a physiological avatar of you and knowing that given your genetic predispositions, both your strengths, as you say, and your weaknesses, you can really focus your program in terms of how to get the most out of it.
So give the listener an idea of what some strengths and weaknesses may look like. Because, when I think of strengths, like you and I look at people, I suspect, I'm taking some liberties here, but I suspect we look at people very differently. Since I've been working with you guys, I'll look at someone, I'm like, oh, you have that gene for sure. I'm like, I'm watching you walk down the road, I'm like, you have that gene for sure. You see predispositions, right? You see people with this like glowing skin, I'm like, I know what gene that is. You're like, oh, right? You're like, yeah. And so I look at people completely differently. And I'd love to hear sort of your perspective on why people should use genes and then or why people should run their genes, and then maybe some specific things that they would be able to identify in that process.
Yeah, I can think of so many examples.
Right.
We look at the moment over 180 different physiological traits. So you could pick any one of those for an individual and say, is that important given the...
Give me an example of what a physiological trait is.
So a physiological trait, it could be something like, if we take an example, let's start off actually on the more sort of medical side of things. So there are some traits that we look at which are more significant, shall we say, in terms of if you've got them, you really need to start there from a longevity and a health perspective. So familial hypercholesterolemia is one of them. This is a genetic condition. It's seen in around 1 in 200 people, so it's rare, but it's not unusual. And if you have this particular variance, I think the statistic that blew my mind actually was if you've got this variance and you're a man, you've got a 50% chance of having a heart attack before the age of 50.
Wow.
It's linked to increased levels of LDL cholesterol in particular, and cardiovascular risk, essentially. Now, these individuals actually should be on statins. So this is a medical intervention that's required for this particular trait. If you've got high cholesterol with this and you've got this particular condition, then the medical route is definitely the right one.
How early in life?
As early as possible.
As early as you see it?
As early as possible, yeah, absolutely.
So I'm not a cholesterol or a lipidologist. I'm not a cholesterol expert, but it just seems so unusual for like, I'm 30 years old and I have and maybe I don't have elevated cholesterol yet, or maybe I do, but I have this gene. I'm like, I got to take this pharmaceutical. I was like, I have to believe there's some other way. Maybe not yet, but hopefully in the future. Sorry to cut you off.
No, absolutely. I mean, it's for the majority of people with high LDL cholesterol, and I think this is what the genetics brings. If you just look at the blood test, someone's got high LDL, the first course of action should be, in most cases, dietary.
Sure.
It should be looking at your exercise routine, bringing in more activity and diet. I've got a personal experience of this myself, actually, because with my couple of years ago, I was at a family dinner. My sister announced, she's 2 years younger than me. She was in her late 30s. She said, I've just been diagnosed with high LDL cholesterol. Doctor says, I've got to do something about it. They're talking about statins. My mum piped up and said, I've had this for 20 years. The doctor keeps trying to put me on statins. I've been avoiding it. I don't like the look of the side effects. I've been trying to deal with it with diet. My mum is like me. She's a healthy weight. She goes to the gym 3 times a week. As far as she was concerned, she had a good diet. But she'd been struggling, and unknown to me, over those last 20 years with managing her cholesterol levels. We know this from our family history, a huge risk of heart disease in our family in particular. So this was always the thing that she felt was going to be her, the thing that got her.
Yeah.
So I said, well, let's have a look at it together. Let's see what we can do about it. We looked at the genetics on the Fitness Gene site, and surprisingly, we all had an increased risk for this particular sort of cardiovascular risk. We looked at what dietary interventions we should be doing. And I said to them, right, we'll all do a blood test together. Day 1, we'll do one in 3 months' time. All I want you to do is eat more of these foods. And there were 7 or 8 types of foods that we put in there, a couple of supplements as well. So the supplements were psyllium husk, which is a fibre-based supplement, and garlic supplements. And then there was oat bran, because it's got the beta-glucan in particular, rather than porridge or oats, which is also good, but not quite as good as oat bran. Almonds and walnuts, apples. We had phytosterols in the sort of the butter spreads and the yogurt drinks that you can get. What was the other one? Flax seeds was another one as well. So we're talking about whole foods and just eating as much of these as we can in the diet. So not really a prescribed diet, but just eat more of these foods. When we got our results back in the 3rd month, my cholesterol had gone down 17%.
Wow.
My sister's had gone down 19%, and my mum's had gone down 24%.
Wow.
And she was nearly back within the normal range. So just the impact of that understanding of what foods to eat was really significant.
Do you guys have just the heterozygous variant, or do you have the like full-on familial hypercholesterolemia? That's the tongue twister for me.
We don't have familial hypercholesterolemia.
You just have one of the genes?
We have, with cardiovascular disease, it is a very complex genetic trait. So it's not just one gene, it's a whole number of different genes acting together, and it's what we call a polygenic risk score that we use with the cardiovascular disease risk.
Right. So Alex, why don't you walk me through the genes that are related to cholesterol? Not all of them. Maybe just give me an overview of all the potential things someone could watch out for. Someone sitting at home, and we talked about this prior to recording. I think there's a lot of people who've done the genetics and didn't get any benefit from it, or like they didn't know what to do with it. That was me. Like I saw it and I was like, this is interesting, but I don't really feel like this is applicable to my life right now. This is 10 years ago. But now I'm like, oh my gosh, this is incredible. So when someone's looking at their cholesterol genes, well, when you're looking at someone's cholesterol genes, what are you looking at? What do you see? And how does someone who's sitting at home actually get some value out of this? Because to most people, it's either some numbers or some information. Like, what are we actually looking at? So where I'm getting at is there a digestion consideration? Is it how your body produces cholesterol? Is it the liver's ability to break it down? Like, what are all the things that are involved in, what Alex is saying here is, or Sam's saying here, one of her family having elevated cholesterol?
Yeah, I think so. So heart health is one of our most populated health categories. So we've got 15 in total. I believe we've got 28 individual reports that sit within heart health. So LDL cholesterol would be one of those. So for each of the reports we look at, we have a scoring system, a relative scoring system, which goes from low priority, you carry a low burden of gene variants associated with, in this case, increased LDL cholesterol, all the way through to critical. And that familial hypercholesterolemia would be one of the critical results, where if we saw that, we would draw an individual's attention towards that and say, this is something that you need to go and speak to.
Is that polygenic? If someone says they have familial hypercholesterolemia, is it one gene or is it many?
So we're looking at a single gene in that
Got it.
case. So LDL cholesterol would be polygenic. Familial hypercholesterolemia would be a single gene that we look at.
So what is happening at the gene level? When we hear somebody says has familial hypercholesterolemia, what is that gene? What does it do? And why do we know that it causes high cholesterol? Can you break that down?
It's a good question. I'm not sure my background allows me to break down the exact science behind that. I don't know if you're more familiar.
Not directly with hypercholesterolemia. I mean, with the polygenic risk scores, a lot of them, we don't actually understand the mechanisms behind.
We just know that there's multiple things that give you that.
We know that if you carry this particular burden of genetic variants, that within a population group, you're more likely to have that particular condition. But it's a good point, Ben, because the one thing to be aware of with this type of gene test is that in the majority of cases, just because you carry a particular genetic risk doesn't mean you're going to develop that particular condition. I mean, another great example of that, which people are very familiar with, is the ApoE4 genes. We know that there's a particular gene, an ApoE gene, E4 it's called, and if you carry 2 copies of this gene, you've got somewhere between an 8 to 10 times increased risk of developing Alzheimer's as you age. And there was some research that came out recently that started to suggest that it could be mechanistic, as in that gene is having some impact on the system level. It's not just an association. But it doesn't mean that if you are a carrier or if you have 2 versions of this gene that you will develop Alzheimer's. It's not a genetic destiny. And we're understanding more and more about types of interventions that people can take to mitigate risk and to delay the onset of neurodegenerative diseases like Alzheimer's.
So that was one of the challenges that I had when I originally did genetics, is like we didn't understand mechanism. We just understood predisposition. We understood predisposition. And it seems as though, since speaking to you guys more recently, a lot has changed since we first did it, which it has. So what level of confidence can people have in their genetic score, their genetic SNP readouts, actually saying, hey, you're very likely to have this thing? Is it speculative at this point, or we can say like, hey, no, you're very likely to, like, what degree of confidence, I guess, is what I'm asking.
It varies within each individual report because each report we produce, we look at the science and the evidence. We've got a science team that do the research. They look at what we call GWAS studies, genome-wide association studies. They do the modelling, and then they work out where to categorise people within the particular bands that come out of it. So ultimately, for some traits, there's a very strong, tight association. So hypercholesterolemia is one. ApoE also has a tight association. Trying to think of some other examples. Actin-3 is a great one, actually. Again, you'll have heard about this if you're interested in sports genetics, because it's the gene for power, for speed. It's been found in every top power performance athlete ever tested, bar one individual, which was a Spanish long jumper, which again just goes to show that
He didn't have it.
He didn't
Everyone
have
else
it.
did.
Everybody else did.
That's crazy. So they have one variant or 2?
There's essentially 2 variants. So if you have that particular gene, it's a single gene variant again. If you have 1 copy of the gene, then you can produce the protein. So this one does have a mechanistic effect. So if you've got 1 copy, you produce the protein. If you've got 2 copies, you produce twice as much. But if you have no copies, like myself, you don't produce the protein at all.
Interesting. So someone who produces twice as much, will they be more likely to be even more athletic?
It has its advantages. So as we've seen, it's associated with power performance. And some of that appears to be to do with fast muscle fiber performance. It's also associated with muscle recovery as well. So, and this is a great example actually for someone that didn't carry this particular gene, that wasn't producing the alpha-actinin-3 protein. It's even more important for these individuals to sort of have enough time of recovery in between exercise to allow their muscles to recover.
So it has to do with recovery, or it has to do with
so actually sort of protection of against muscle damage. So people who don't produce alpha-actin-3 are more likely to see increases in muscle damage following like resistance exercise, especially during sort of eccentric contractions. So actually looking at sort of recovery protocols for those individuals. And it was only about 10%. Both myself and Sam do have that genotype. There's only about 10% people within the population.
Do you think that unconsciously created an avoidance of exercise for you guys? I mean, I have no idea. Would it have created like I want to do more of that or less of that? Did you guys have any similarities on like what your beliefs were, what your desires were to pursue exercise?
So there is some association with the lack of alpha-actinin 3 protein and also a predisposition towards endurance performance. And I think that's definitely something that I've kind of sort of has run true for me as I was sort of like growing up. And then since taking the test, it's allowed me to kind of really focus my efforts around what type of training, what type of activity that I do kind of pursue. I'm sort of long distance runner, sort of triathlete by background as well. And so I've definitely seen more success in tailoring my training, my recovery and my kind of events that I sort of target around kind of that endurance performance as opposed to, straight resistance training or kind of more explosive power-based activities.
Yeah, I was just wondering if someone trains and has like excruciating soreness afterwards, like I don't want to do that more. That's interesting because there's some. Do you know what percentage of the population has that? Some percentage, and a lot of people are like, I don't like to exercise, and many coaches are like, too bad, get over it. But if you know that they have this gene, you're like, oh, I can support this.
Increasing problems, yeah, no, absolutely. And I mean, I started taking creatine. That was one of the recommendations associated with that particular category because that does help with muscle recovery as well. And that's had a really positive impact for me. And of course, now we're seeing more and more research on creatine coming out, having additional benefits beyond just the muscle recovery. No, that was certainly one of the changes that I introduced after learning that I had that particular gene variant.
But also alpha-actinin 3 is associated with increased response to resistance training and increased testosterone levels as well. So if you find like a client doesn't produce that, you can almost sort of set some expectations around the progress they may make over a period of time. If they feel like they're sort of making slow progress, there may be sort of biological reasons as to why that might be as well. I mean, that's just one example. We look at things like mTOR and IGF-1 and other things.
That's where I'm going next, Alex. That's where I'm going next. So, my audience is like, well, tell me about the muscle building genes. And so while a lot of people sit at home and they say things like, I can just do any workout, what we acknowledge and we recognize is the variability and level of effectiveness in a workout is huge. And most people are like, yeah, the canned response is I'm pretty good. Like I train pretty hard.
Yeah.
And I'm like, what does that mean? So I would love to have you start, guys. You can, take whoever wants to take a stab at it. Walk us through like what genetic influences can we look for, and what outcomes or what operationalization of those genes would we look at? So, is there a specific number of genes we'll look at when it comes to muscle building, and then what would he specifically be changing with respect to our diet, nutrition, and training?
Yeah, so I mean, training structure is a really interesting area for us, and it's very much kind of where we started as a company, like trying to provide people with that direction, because we, the same as you, saw people responding to different types of training strategies in different ways. So we create a model at our end where we combine different gene variants to make those prescriptions. So like training frequency, for example, we look at, I think for that one, we look at about 5 different genes at the moment, where we look at an individual's ability to recover post-exercise. So, actin 3 will be one of those genes. So we just group people based on sort of low, medium, high frequency. So low frequency maybe kind of 3 times per week. And we also consider kind of their training age within that as well. So making sure they get more recovery than someone who may be training kind of 5-6 times a week based on those genes that we look at. But then within kind of looking at like training volume, looking at tempo, rest periods, we actually look at a combination of 22 individual genes that we use to create sort of a stratification that we can place people within and make much more specific recommendations in terms of, this is the number of sets and reps you should be doing per workout based on your genotype, or, you should be doing 30 seconds between sets or up to 2 minutes based on intra-workout recovery, for example.
And so how confident are you in those diagnosis, right, those prescriptions?
Yes, I mean, for us, it's very much just looking at the research that is available to us, and that is sometimes kind of the limitation and the restriction. So we've got our own in-house science team, so any research that is available, we do look at, and as that research continues to grow, we'll be able to be more specific because we have that team that looks at the research continually.
I'll tell you one thing I've seen though, anecdotally, is that I know a lot of people have been training for a long time, including myself. And when I looked at my genes, I was like, yep, like that's what I've landed on after 20 years of training. Right? I'm like, yep, I do this and I do this and I do this. And like, it's like, oh, that's interesting. Like I didn't think about that one, but that would be like inflammation, for example. I think had I known that I had poor poor inflammatory genes, I would have changed the way I trained.
Yeah.
But I didn't even think about its role, like way back in the day. I was like, it's just part of the process. Like I didn't realize there's going to be like different levels of inflammatory response to the same workout program. Right. And I don't think anyone sitting at home realizes that either. Like all three of us can do the same workout. I have the actin-3 gene, you don't. We're going to respond completely differently. That's one gene. There's probably an infinite number of genes that are also going to affect how we respond to all exercise programs.
I think that's really interesting what you said there, actually, Ben, because that was our experience. Obviously, it's anecdotal, and you know, we're a science team essentially at Fitness Genes. So as Alex says, when people say what's the evidence behind it, it's effectively drawn from the peer-reviewed research, because that's what we do. We interrogate the peer-reviewed research and then we present it to our members. But the feedback we were getting anecdotally from the people we were working with, we very much started off in the muscle building space, in the bodybuilding space. And the feedback we were getting from the professional athletes that we were testing was, this is really interesting. And actually, it's telling me a lot about what I've already learned through trial and error over the past 20 years of working out.
Yeah.
And I guess what we realised, what people would say, is this actually something which is for a professional athlete? And actually it's not, because from my perspective, it's telling professional athletes in the majority of cases what they already know through their own trial and error, which is great for them. And as you said, perhaps there is sometimes an interesting sort of...
There's always missing things.
The missing thing that they hadn't thought about. But actually what it does, it's for the individual that perhaps is coming to sort of self-improvement or hasn't worked out in a long time. It's giving them a really sensible starting position, because it's telling them, based on your unique biology, these are the things that are likely to be most important for you.
It's so simple. It's the signal when everything else is the noise. There's so much information, and there's so much dogma being spewed everywhere. This is what you got to do. You got to do this. You got to take this supplement. I was like, what are you talking about? Who needs to take that supplement? Who needs to do that workout? Like, have you run your genetics? Have you looked at anything? Like, no. Well, then stop spewing nonsense until you look, because there's so many things that are so unique to your individual biochemistry, your unique physiology, and like, you have no idea. And like, yeah, we have some idea. Like I would say, I've been doing this for 25 years. I can look at most people and be like, you're probably missing this, or like, hey, that thing, you know, you're not sleeping while you're stressed. This would help, but it's not like laser targeted, right? And since doing the genetics, it's like, oh, it's this is our, you know, and we may have three things that we're like, this is where we got to double click on. Let's focus on those. And that's what's beautiful about your system, is like, you guys have put together these traits or these reports that we can be like, okay, based on this trait, this report says I need to do these things. It's super useful. It's a lot of information, which is why I want to have you guys on to sort of sort through it all. Because most people are going to pick up those reports, including all of our clients that watch this video. And they're going to say, hey, this is a 380-page or 400-page report. What the heck do I do with this? So, Alex, I'd love to have you tackle like some terminology that can start familiarizing our audience with, like, what are we talking about when we're talking about single nucleotide polymorphisms, and like what are all the common terms that someone would want to know to be able to even navigate? You guys do a good job in Fitness Genes of simplifying the terminology, but I think people are hearing genes on other podcasts and certainly on this one at some point. So what is there any 3 to 5 terms that are like, you got to know this and here's what this means?
God, yeah, it's a good question. Genotype, I think that's probably the best place to start. So actually, what is your individual genotype? So which sort of group do you belong to based on the combination of your genetic variants? Variant, that's probably the next place to go. So what's the best way to describe this? What is the specific, I guess, base within your genetic code that you carry, which influences the way that your DNA is transcribed?
So what's a base? So genetic there's like, what, do you have a genetic sequence? We'll take a little snip of it.
Yeah, let's start right at the top. So we have a cell. We then have a nucleus, and then within the nucleus we have chromosomes. So we have 23 pairs of chromosomes. And so this is present in every cell within the body. So in terms of analyzing someone's DNA, in theory, you could take any kind of cell to run that analysis. We use cheek cells, so we get clients to spit into a test tube just because it's non-invasive and probably the easiest way to do that. So within those chromosomes, we have around 21,000 genes that are broken down into what we call sort of nitrogen-based pairs, and these can be 3 nitrogen-based pairs are known as a nucleotide, and these sort of a gene can be, you know, hundreds of thousands of base pairs long, and they're almost like rungs of a ladder. So it's the connecting parts that connect two sugar phosphate backbones, which is kind of then twisted and kind of misshapen to kind of present the chromosome. But if you were to strip that out, essentially what you'd get is a ladder shape where it has nitrogen bases that are all paired together. When you're then producing proteins, what happens, to kind of cut a long story short, is this ladder gets pulled apart, read, and the sequence of the base determines the protein that's produced. So when there's variation in those nitrogen bases, that creates variation in the types of proteins that are produced, and that can influence an individual's response to different nutrition, exercise, supplementation strategies. So we're looking for very, very small individual changes within that nitrogen base sequence that can have a sort of cascading effect to, determine any sort of number of characteristics that an individual may display.
So it's transcribing new protein. So all DNA does doing is like, hey, I'm going to create this new protein, and this protein codes for something.
I think that's probably the easiest way to describe what we do. Is we're looking to establish an individual's protein profile, and it's just that DNA is the thing that kind of informs the structure and the types and the levels of those proteins that we can then use that information to make our recommendations.
So what's a SNP, Sam?
A single nucleotide polymorphism.
Makes perfect sense. I got it down.
If we break it down,
Yeah.
it's a change in the DNA sequence. So the majority of our DNA sequence is identical in terms of my DNA sequence and your DNA sequence. 99.7% of it will be identical. There are some changes between our sequences and between the sequences of other animals as well that essentially distinguish and make us who we are. And a single nucleotide polymorphism may be something like within a particular gene sequence where I will have an A base at that point, an adenosine base. You might have a C base as an alternative. And that difference has led to some sort of physiological difference between us. It's had some sort of impact.
Isn't that crazy?
Yeah.
So yeah, when you break it down and you look at sort of how far down the sequence you go to then pick out that sort of variation that we're looking for, then yeah, you are dealing with kind of very, very specific changes within an individual's biology for sure.
I mean, there's a fascinating. I'm an evolutionary biologist by background.
Oh, that's
and
I was yeah.
There's a fascinating example with one of the genes that we look at, which is the lactose tolerance gene.
Yeah.
So whether someone can digest the lactose in milk, or if you can't, you don't have the lactase enzyme, it can give you a really bad stomach upset. So we all know if someone's intolerant of lactose, you get the bloating, you get the bad stomach, gastrointestinal issues. It's an intolerance rather than an allergy caused by the fact that you can't break down the lactose in dairy. Now, there's one variant that we look at which is prevalent in the majority of Northern Europe, and it's had such a strong evolutionary advantage. It's spread through most of Northern Europe. If you can imagine, in the olden days, if you could drink milk as an alternative to water, which was very, very often polluted or contaminated, similar with beer, actually, weak beer is another way, and one of the alcohol tolerance genes is also very prevalent in Northern Europe as a result of that. But it gave you an evolutionary advantage. So people who were able to literally stomach periods of sort of drought, or when they had to drink milk as an alternative, they went on to pass on their genetics. Individuals who didn't have that advantage would tend to die earlier, and that was the evolutionary sort of spread of that particular gene. Now it has such a strong evolutionary advantage in humans to be able to tolerate milk that single nucleotide polymorphism in Northern Europe there's a different, around 4 or 5 different SNPs have arisen in different Northern African populations, all related to pastoral herds. So the evolutionary advantage of being able to drink milk is so strong that independently new SNPs have emerged across multiple populations in Northern Africa associated with dairy farming. So it's a completely different SNP in a completely different place in the gene, but it still knocks out the off switch that turns off lactose that happens in
So what's the advantage of
adults.
being lactose intolerant then? So you're saying most Northern Europeans are intolerant?
Tolerant.
Tolerant.
Yeah, tolerant.
Interesting.
So the ability to digest lactose during periods where
Yeah.
food is diminished.
I thought you said intolerant.
No.
So what's the advantage of being intolerant?
That was the ancestral states. So that was how everyone was until the evolutionary advantage
Got it.
gave that additional benefit to some individuals.
Right. So is it safe to say if the Northern Europeans are lactose tolerant, that people around the equator are less tolerant?
Yes.
So what's your evolutionary biology lens there? I have my theory that's coming up in my brain, but I want to hear yours.
In terms of why they haven't, I mean, it's to do with, I would say, because we're seeing it within the dairy farming communities, it's to do with access to dairy, essentially, ready access to
So
dairy.
you don't think people around the equator would have had access to dairy? They would just be eating different things when there's a drought?
Possibly, yes.
Super interesting.
Yeah.
But also to put that in context, so that single sort of variant is one of 3 billion sort of nitrogen bases that, you know, is within the human genome. So even sort of the significance of that, you know, within that much larger kind of like database, that's kind of, yeah, the granularity that we're looking at within this genes.
Right. Remarkable. So what other terminologies do we need to know? So we talked about SNP, talked about genome. You got a few. What do you got, Sam?
I'm just trying to think. I mean, I think when it comes to
Variant. So we know there's 3 versions of a gene, right?
Mhm.
We can have, well, I'll let you walk me through that. What do we talk about when we say like, hey, I've got this version and this version? Okay, I know there's generally 3 versions. Why don't you help the audience understand that?
Well, we've been talking about bases, and I guess the important thing to know, and I think most people understand, that you get half of your genetics from your mum and half of your genetics from your dad. So essentially, they've provided half of the DNA backbones that Alex was talking about that then come together. So your mum might give you an A base in one case, your dad might give you a T base, or might give you an A base as well. So this is why essentially when we're looking at single nucleotide variants, we're saying you could be AA, AT, TT. You've always got 2 versions of it. So if it's a single gene variant, generally there's 3 bands that you can fall into. So you could be, for example, AA, or if the alternative SNP is a T, you could be TT, or you could be AT. So that gives us 3 bands for any one gene that someone may belong to.
And so if we're having a conversation about that, what would I call that? Like a variant? Would I call that?
That is your genotype. So that is, as Alex was explaining earlier,
So-
that is your genotype.
I have the TT genotype. Is that
Exactly.
that would be the nomenclature?
Correct.
Yeah.
Yep.
And so talk to me about, we talk about like, I've heard like wild type, heterozygous, homozygous. Tell me about that.
You've been doing your background reading, clearly. So yeah, homozygous is carrying one of each. So like, for example, it might be AA or TT. Heterozygous would be, the same of each. So heterozygous would be like AT or TA, or sort of one of each variant. Sorry, you have to remind me what the...
What's a wild type?
Do you want to take wild?
Yeah, it's exactly what we just talked about with lactose. So the wild type would be the lactose intolerant version. You'll have to excuse me, I can't remember which A and T it was, but that would be the ancestral version.
So like
Would be
the
the
one.
wild type.
So what's fascinating to me when you said you're an evolutionary biologist, the fact that we've got 99.9-ish% the same and such small variants, what an incredible thing to think about. How most, sounds like mammals, I know we're very similar to pigs, I've also heard, are almost identical at a genomic level. And the fact that we all have this same foundational molecule, what do we call it? What's a chromosome? Not a molecule, it's a structure. Every mammal, am I correct in assuming every mammal has chromosomes and genes?
Yes.
And they're all the same, 99% or close? A lot?
But outside of mammals as well, all sort of living biological
It's
things.
just remarkable to think about that.
Well, yeah, I that used to blow my mind. But then when you think about complex sort of processes like respiration and, you know, eyesight and all these very, very complex
Of
kind of
course.
like biological processes that everybody shares, then you think actually kind of like the variation that we see, you know, we do share a lot of information which just allows us
Right.
to function as human beings, and then the variation exists beyond that as well.
I'm more blown away by the fact that everyone has, like, everything on the planet has the same, like, we're all made of carbon and we're all made of chromosomes. It's so crazy to think how closely tied we are, but yet we always focus on our, like, we're so different.
Yeah. I mean, I think it's something like you share 60% of the genetic information of a banana or something like that.
Huh.
So, you know, even sort of like down at that level. So yeah, the chimpanzees is the classic example of like 99.5 or whatever it is, because they're so similar. But actually, when you're looking at any kind of like biological being, there are key processes that everyone needs to kind of have and to just exist as well. So yeah, it's a fascinating subject when you dig into, and Sam knows far more than I do, but
Yeah.
it is a fascinating subject when you dig into.
Sam, you talked about some like real life examples of things that may be preventable or things that may interest the audience. Of like, hey, you may want to look at this gene because I've got a number of them. It sort of blew my mind. I was like, oh my goodness, if I would have known this when I was a kid, or I would have known this when my children were little, it would have completely changed my ability to be a parent. Anything that stands out to you as things that are interesting, exciting, or that should be must knows for the audience?
Oh, so many. When it's like being a kid in a sweetie shop trying to think where to start.
Right.
I was going for another one that is meaningful to me, hemochromatosis, because this is a genetic variant which is very prevalent actually within the Irish population, the Northern Irish population. It's prevalent at around 2 to 3% in the general population, but in the Northern Irish population it can be as high as 10%.
Wow.
And I'm a carrier of this particular variant. And it's a condition, hemochromatosis, hereditary hemochromatosis, which essentially means you absorb too much iron from your food. And the iron can build up in your cells over time. It's generally symptomless. You don't see any symptoms until your 30s, sometimes your 40s. But all of the problems are going on underneath at cell level, and the cells are becoming damaged from the exposure to the excess iron. You can end up with serious liver damage and damage across a number of different organs as a result. And most of the time, the first time people learn about this is when their systems are failing and they're having to go to the doctors with some quite significant symptoms and getting to the point of requiring organ transplants, which is of very significance. Now, there's a genetic variant we look at which can identify whether someone is likely to suffer from hemochromatosis. And again, I say likely to because not everybody that carries it will have high iron levels because it's very much dietary led again. If you know you've got this variant, you can have a look at dietary interventions to manage it, to reduce the level of iron in your diet, to reduce or the way in which you combine your diet. So we all know that tea and coffee, if you drink tea and coffee after an iron-rich meal, it will prevent the uptake of iron. Vitamin C-rich sources like citrus fruits have the opposite effect, so they will increase the absorption of iron. So starting to think about how you sort of structure your diet becomes really important for these individuals. Bloodletting as well. So another advantage, giving bloods on a regular basis will also help them manage their excess iron levels. And this is something, if you've got this particular condition, you want to know it in as early as possible, essentially, because then you can have the education, you can manage your diet going forward, and you can effectively completely mitigate the impact of having this particular genetic condition and avoid having those problems in later life that many people aren't even aware of until they're suffering the consequences of them. And that's just one trait, again, that we look at that can give some really vital information for that individual in terms of triaging them to interventions that they should be considering.
Yeah, but this also comes into your point about heterozygous versus homozygous, because you could just carry one variant of hemochromatosis and it not present because you've only got one variant. But then if you have two people who both carry that risk variant, they have a child, they have the homozygous version, then hemochromatosis may present in that child. So even like things like family planning, you can sort of take into consideration some variants that you and your partner may carry as well.
Super interesting. One of the things I was drawn to in the genetic panels is all the neurotransmitter stuff. So like looking at all the dopamine and the adrenaline and the catecholamines, that was really interesting to me. And now to start talking to people about their genes, looking at their genes and going, oh, like there's a personality. So where I've sort of landed, I'm curious if you guys think this is accurate. I've landed on your genetics. Again, you can correct me in any inaccuracies. Your genetics seems to maximally influence your physiology, right? Your biochemistry, your physiological reality. So your physiology is reacting with your environment, your lifestyle from the time you're born. So, and because we all have unique physiology, we also have unique lifestyle. Your physiological response to the environment is going to start to shape your personality. So as an example, someone who has acute adrenaline response that's very high, like, well, you're probably going to be more likely to be avoidant of things that are stressful. It's probably going to feel more overwhelming and more stressful. Maybe you become anxious. Maybe you become avoidant. And that isn't a personality trait. That's a physiological response to your genetics, or physiological response at a genetic level to your environment. That isn't a personality, but your personality forms because of it. So it's an interesting thing to start looking at. It's like, well, how much of your personality is like unique to you versus like an expression of your genetic predispositions? That might be something you can actually shift. So someone sitting at home being like, oh, I tend to have an anxious avoidant personality. Like, yeah, as soon as I see that, I'm like, I know what gene that is. I'm like, you're probably this. I don't want to talk about details, but you probably have this. Let's look. So maybe you have a high acute response, high baseline, long tail, right? You're like, oh, okay, that's my son. It's me. You're like, oh, these people may be likely to not want to be in stressful situations. I think that's why I found exercise so young, because exercise for me has been this amazing outlet to like, I was probably an anxious kid, and like, now I'm not at all because I exercise every day, and that's almost become my drug to alleviate this anxious tendency. And you're like, well, everyone needs to see this. Like as a child, my son would be very reactive. He would drop something and get very upset. And I was never like dismissive. Maybe like in my mind, I'd be like, hey, buddy, it's okay. Like no big deal. In my mind, I was like, no big deal. But to him, it was a massive deal because from the neck down, he was so overwhelmed. But if I would have known that as a parent, I could have dealt with that so differently. So I'm curious if there's any specific genes around neurotransmitters, stress, catecholamines that you guys maybe had personal interest in, or that you find to be really influential to most people.
I mean, we released one last week, which I think is really interesting. So we look at cortisol and stress response. So that's one, as I say, we've got in-house teams, so we're continually looking at new research. So that's one that's literally only just been out for the last 5 or 6 days or so. And that was one that we saw, huge engagement with all of our members because cortisol is such a hot topic at the moment. So
can you differentiate between that snip and the adrenaline snip, and how one would like, because those two things often happen together.
Yeah, and I think this is where it maybe gets slightly complex, because then how are these things weighted against each other, and what do you prioritize? So I think our way of addressing that is by giving people that relative scoring. So rather than saying, here's 180 bits of information, look to optimize all of them. Yeah. It's okay, let's look at your adrenaline, let's look at your cortisol, let's see if there's any relative risk there. And if there's not, great, let's go and look at inflammation or gut health, and let's just see what improvements we can make. But if we do find that someone is more, responsive to cortisol or increases in cortisol and stress that stays higher for longer, then we can encourage them to take some preventative actions when they do find themselves in those stressful situations. So, just off the top of my head, that was one that I personally found really interesting. And we're looking at the same gene in relation to body composition as well for our next report. So there are different ways that you can look at the same research and cut.
I dropped that with my audience and not tell me, well, what's the gene with body composition?
So cortisol and body composition. So actually how, and you'd have to speak to the science team to get the detail. Obviously, they're still kind of compiling it at the moment, but how someone's response to cortisol can shape things like their risk of weight gain, for example, or their body muscle building results as well. So the same kind of information, but just looking at it from a different physiological angle.
I definitely need to get the science team on, because I'm so curious how they weight, like weighting the adrenaline, cortisol, or like adrenaline or cortisol and fat loss. How do I put 7 genes together and determine which is going to have the greatest impact on this outcome and which may have the least impact on the outcome?
That's kind of, yeah.
Yeah,
we rely on their expertise.
Yeah.
That's where they earn their money. Just look at their understanding of also how kind of impactful certain genes are. So the cortisol and adrenaline, for example, they may look at that and say, actually, based on the evidence we looked at, cortisol, there's a much higher kind of genetic factor at play here. So therefore, the way that we score that is going to be different to the way that we score adrenaline. So it really depends on kind of how things relate to one another and their understanding of the science behind it as well.
So Sam, with respect to the same question, is there anything that you have personally, genetically, just with respect to neurotransmitters, maybe catecholamines, that when you first discovered it, changed the way you thought about yourself or the way you approach life?
I mean, I think I probably had a similar experience to you, Ben, in terms of, I think it's it makes you more self-aware as to why you might behave or have a particular response, and looking at your kids as well. And I've got 2 of my own, and seeing as you said, you do look at them and think, how much of this can I break down to environment because of the way in which we're bringing them up, and how much of it is genetic. We've got 2 kids and they are polar opposites.
19.
It's insane how different they are. My daughter, she's the singer, she's the dancer, she wants to be front of stage, the leader in the drama shows.
Right.
She got the lead part in the Christmas play, singing. And my son, on the other hand, is a complete introvert. He's
Sam,
quiet.
I hate to remind you, that sounds exactly like you and your husband. I'm just going to let you know.
Yeah, I wonder where they get that from. Yeah, absolutely.
Yeah.
And you sort of look and you think, wow, actually, you can sort of see the way that our own sort of genes have been split up amongst our kids. And it does make me more thoughtful in the way that I am bringing them up, because I want to support both of them and they both need different things in their own way.
Right. So what would you chalk that up to? No, being a geneticist, you go, oh, this child does this and this child does this. What is that? Is that like a specific neurotransmitter amount? Is it like receptor? What would you say has the greatest influence? Because, someone who's got dopamine levels that are elevated is going to be very different personality than someone who has low dopamine versus someone who's got high serotonin. It's like, as a geneticist who knows more about this stuff than I'll ever know, how do you look at your kids, how their personality has been shaped? Are you curious about their neurotransmitter like balance, or are you just like, I don't think about that at all? You're crazy, Ben.
To be honest, I mean, one of the things that we did when we set out the company originally is we decided we were not going to test children.
I cheated, you know that. I cheated. I have my kids. I won't tell anybody that, but I did.
The reason that we did it, it's not a legal requirement. It was an ethical sort of a decision on our part, because we knew at the time that there were people that were using this type of testing to put children in buckets, essentially, to say you should be doing this particular thing.
Right.
And the one thing we want to be really clear on, and as we sort of discussed today, is that the genetics is not your destiny.
Sure.
It doesn't mean because you carry a particular variant that you're going to have it, in the majority of cases. There's obviously always caveats. There's a few very sort of penetrant sort of genes that we look at, but for the majority of the cases, it is about predisposition, and it's about what can be. It's like almost thinking like, if we're thinking the ghost of Christmas sort of future, it doesn't have to come if you change the environment that somebody is in, which is an interesting way of thinking about it.
It can be empowering, right? Like
exactly.
Yeah.
I mean, all of the recommendations we provide are proactive or suggest replacements for things that people may be doing. It's never sort of, don't do this type of exercise or cut out these types of foods. It's always, what can people do? What can they add into their nutrition, their exercise, their sleep routine to help maximize their health and performance?
So we're all on a journey, and I always call it a progressive narrowing toward a worthy ideal, right?
Okay.
Like, we start here.
Yeah.
We have all this information, all these things we could do, and we're like, well, that doesn't work. It's like process of elimination. Eventually, it's like, boom, now we get the right thing for us right now based on our goals.
Yeah.
And so genetics just takes you from here to here in a lot shorter amount of time.
Yeah.
And it's just such an incredible advantage. You didn't answer my question. So you haven't run your kids yet? Did you say that what you said?
I haven't.
So
Believe it or
even
not.
if you have it, you know what their tendencies are. Like from an evolutionary biology and genetic perspective, you don't ever look at them and go, oh, that's like a dopamine dominant thing right there. You don't ever do that?
I have to say no.
Oh man, I got problems.
I think I think there's so much more with, as you said, lifestyle, and this is again where it comes in. Lifestyle is so important, and it's almost a case sometimes in there. The genetics is giving you the focus, but ultimately it's the lifestyle that's going to mold the individual.
Sure.
And that's with our children.
So why are your children different? They're in the same environment and lifestyle.
Yes, but they need different levels of support. Obviously, they need support in different ways. So as you said, there's likely to be a biological rean that underlies it, but I don't necessarily in them need to understand
This
it.
doesn't keep you awake at night like it does me? I'm just kidding.
I'm a night owl, as it turns out, anyway. So that's one part of my. I mean, there are some parts of the genetics which perhaps are more, for curiosity purposes. And I think one of the things that I found fascinating in my results is that I'm a very strong night owl. And I think this is the case in a lot of the results, is it takes some of the guilt away. I've always worked best in the evening. I'm terrible in the mornings. If I have to get up early for any reason, it takes me a couple of hours to really get up and running.
Right.
And in understanding from my results that actually I'm wired from a circadian rhythm perspective to operate better later in the day, it just made so much sense to me, and it changed. I stopped fighting it. I stopped trying to be the entrepreneur in the gym at 5 a.m.
Totally.
And I run with my own rhythms now, and that means working.
Here's a funny reality. So my son, his genotype said he's the sort of a late riser, like an 8:30 a.m. would be ideal for him. And for me, it's like 6 to 6:30. I'm like, I'm exactly like, I'll wake up at 6 o'clock in the morning every day. I go to bed at 10, I wake up at 6 every day. If you leave me without an alarm clock, I'm going to bed at 10. I'm going to wake up at 6 every day. It doesn't matter where I'm in the world. My son will never wake up at 6, like ever. Like he'll sleep to 8:30, 8:45 every day. And you look at his genes, it's like, it says exactly that. Which blew my mind, and it gave me a lot more grace for my son. I was like, well, I guess I can't wake him up because I'm like, you gotta get up. I'm like, no, let him sleep. But any idea what's happening there, like at a mechanistic level? Have you sorted through that? Because I'd be curious, like, why would someone be suited to waking up later, and what's happening like in our, I understand, suprachiasmatic nucleus and hormones, but what would be the either evolutionary advantage or mechanistic mechanism behind that?
Well, I always think about it from the evolutionary perspective, as you know, and I've just did a little bit of reading on it just recently, actually, because obviously the way that society is set up, it's very much focused towards the early birds. The early bird gets the worm. You've got to get in there quick.
So many
people that get up
right?
late are lazy.
Right.
If you stay up late, you need to be getting a good night's sleep. So there's lots of negative connotations with staying up late and lots of positive connotations with getting up early.
My listeners are way too smart to say things that are dogmatic like that.
Now, evolutionary, again, from some of the research I've read recently, they've actually shown that it was advantageous when we look back sort of tens of thousands of years ago. If you're living in small communities, you've got a lot of potential threats from outside, from other groups, from animals. It's advantageous to have a good sort of breadth of individuals in there who are early birds all the way up to night owls, because you get vigilance through more of the day and the evening. And so there's been an evolutionary adaptation to have these groups of early birds and night owls, and people that sit somewhere in the middle as well, of course, because it's all on a spectrum.
Right.
So evolutionary, this is the way that our society has developed. But then along comes modern life. We've got artificial lights. We've got these, as you say, these sorts of modern connotations of what people should be in terms of their behaviours. And it just doesn't fit in for some people with what they've carried through evolutionarily. And there is, a lot of the customers we speak to will say to us, understanding my results, it took away the guilt because I got why I'm that way. So when people say it gives people an excuse, sometimes we have people say, well, it will give them an excuse. Like let's look at the weight loss genes. If you've got a variant which tells you carry a particular variant of the FTO gene or one of these other genes which is particularly associated with weight gain, it gives them an excuse and they won't change their behaviour. We found the complete opposite. We found it gave people an understanding of who they were.
I agree.
And then it allowed them to better target the interventions in order to change that.
I think, like most things, it's going to be split, right? I think when I think of genetics, I think it's the most empowering thing I've ever done. I'm like, oh, I know exactly what to do. It gives me so much clarity. I know I'm going to take action. Whereas I can completely see there's a whole number of people who go, well, I guess I'm screwed. Those are my genetics. And you're like, well, right? There has to be like some version of a split of people who are going to go both ways.
Yeah, I've sort of helped guide people through their results for over 10 years or in the time that I've been with the company. And I'm yet to kind of have a call with someone to sit down and then not be some sort of light bulb moment where they go, oh, okay, that makes so much sense.
Right.
So although we have this kind of breadth of reporting, it might just be like 2 or 3 really key bits of information that they pick out and really resonates with them and helps them understand kind of, their response to certain sort of strategies. And so, I find if you've got to the point where you're looking to be proactive about your health and you're looking to take a test and find out more, then to have that attitude of being quite defeatist is quite unlikely. So, the conversations I have are overwhelmingly, okay, now I know this information, I know what to do with it, I feel much more empowered.
Is ADHD genetic?
I understand that there is an element of genetics to ADHD, yes. I'm not the expert on it, so that might be one where you bring in our science team and speak a little bit more to our chief science officer.
I hear so many people who have these beliefs and they get these dogmatic terms thrown at them, and it becomes their identity. Like, I have this, I am this, and I'm like, are you though? I'm like, is it just an environment thing, or like, did you have a childhood that was a little chaotic, or do you just like do too many things to distract yourself, so your brain's a little chaotic? So I'm very curious about, are there any genes, kind of sort of a side tangent, are there any genes that come up for you guys that were like surprising, or like, oh, there's a gene for that? Like, I suspect in your journeys through genetics, you've discovered some really interesting. Oh, there's a gene for eye color. There's a gene for this, and you're like, oh, I can look at your genes. And be like, you're going to do this. So when you look at somebody's genes, do you know everything about them before you read it, or after you read it? I guess.
I guess usually if I have a call with someone, I'll have a look at their data first, and I'll get usually quite a good picture of who they are as an individual. And a lot of the time it kind of makes sense.
Yeah.
But then sometimes I have a call and it'll be completely different actually. And a lot of kind of like what they're already doing, sort of like their interests, their hobbies kind of aren't necessarily what I expected out of school. So you have to go into it with an open mind. But in terms of kind of those more, I guess, niche genes, around, because we kind of do ongoing research around Christmas time every year, we try and do a slightly more kind of like funner gene, like a novelty gene. So it might be like a bitter taste and sensitivity that we did and related it to Brussels sprouts, or early hair graying we did one year and related it to your hair going white, for example. So there are sometimes things that we can pick out from the data that we look at, which is slightly more of a novelty, but 364 days of the year, we try and be much more focused on the real science.
Funny story on that. My son and I have conflict over one thing: vegetables. One thing. And we run his genes, and he's got the bitter gene, like he's got the highest gene for bitter tasting.
So there is,
yeah.
So
Excuse now.
Now I'm like, I guess I can't make you eat vegetables.
So even though that was intended as a novelty one, there are still some some insights associated with it as well.
Yeah.
So, yeah.
Well, now that my son doesn't eat vegetables, I have you to thank.
Yeah, it sounds like we're really undercutting your parenting at this point in terms of bedtimes, vegetables.
Yeah, exactly. My son's staying up to midnight and not eating vegetables. Thank you very much. I appreciate it. Alex, same question. Anything stand out to you as it was like interesting? Like how that's like, I think as I read through people's genes, there's always, I'm like, oh, I didn't realize there would even be a gene for that. Anything comes up?
I think one that I found quite fun and interesting was the norovirus resistance gene.
Yeah, I see that on the, I don't even know what that means. Yeah, what does it tell me with that?
Well, norovirus, I'm sure, everyone will be familiar. It's the gastrointestinal sort of illness, very famously associated with cruise ships, and very bad. Obviously, we know the symptoms, not nice at all. There's around 20% of people that are essentially resistant to most common forms of norovirus, because they have what I like to call bald cells. So it's there are little antigens that on the outside of our cells to do with the ABO blood groups. And if you have these little sort of lollipops sticking out of the cells, that's the way essentially that the virus gains entry to the cell. Some of us don't have those antigens on the cells, which makes it much more difficult for the virus to get into the cells.
Any virus or just norovirus?
Just norovirus specifically for this one. It's the mode of entry for norovirus particularly. And not every norovirus, it doesn't make you completely resistant. There are some strains that you can still be.
So norovirus is a GI upset virus. I didn't know that.
Yeah.
Got it.
So around 20% of people have this sort of, and I noticed it at the beginning of school last year. We had an epidemic. All the kids came down with this vomiting bug. But we didn't, and our kids didn't. And it occurred to me when everyone was chatting about it on the mum's WhatsApp group, and I was like, oh, I know that I'm resistant to, I've got this norovirus resistance. I checked my husband's results as well. He's also in the 20% of people that are resistant, which means we know, even without having tested our kids, that they are both resistant.
You guys were drawn to each other because you were both not
so that's all we can do. So we managed to avoid the worst of the sickness at the beginning of last year, luckily, as a result of that. So, but it actually does have potential important consequences as well, because one of the things that I've read recently is that scientists have developed a vaccine for norovirus. Now, obviously, vaccine is a hugely controversial topic at the moment, it seems, in a lot of cases. But this is a genuine case where you could make to say that somebody like myself, my kids, my family, we don't need it. we don't need it because we already have the protection on a genetic level. Now, don't get me wrong, I'm not anti-vax because all my kids have all of the vaccinations for common childhood illnesses, which they, would be impacted by. And I think it's really important to state that. But I also think it's important that everything is taken on a personalisation level. And I think we will look back in, hundreds of years' time on this period of early medicine as we might look at it then and say, wasn't it crazy that we just gave everyone
Generic stuff.
exactly the same treatments and we didn't tailor our treatment to the individual at all? And I think that's what it's got to come down to.
I think we're closer to that than we realize. As you guys are working so diligently on artificial intelligence in your community, so is everyone else. So I think it's, I think we're getting there. We're getting there. I think we're very close to understanding who you are uniquely and giving you what you need to thrive, which is interesting because the implications of that are vast. Fun. We'll have to continue that conversation next time.
Yeah, episode 2 coming.
All right, Sam, thank you guys very much for joining me.
Brilliant.
Thank you for joining us in the Muscle Intelligence Podcast. Incredible discussion on genetics. I'm sure you have a million questions. If you want to contact Alex and Sam, I'm going to leave their website in the description. If you want to leave a comment for us down below, we'll do our best to get in there and reply to everyone. Thanks for being a listener of the Muscle Intelligence Podcast, and we'll see you again next time.